Okay, today we're going to be looking at how to rewrite improper fractions. Improper fractions are ones where the order of the top is the same or bigger than the order of the bottom. So we've got a nice, simple, straightforward linear divide by linear in this case. Two ways of doing it. One, the way I prefer to do, which is just set it up as if when I do my division, linear over linear, I'm going to have a constant, as it were, like a whole number part of a mixed number, and then my remainder divided by whatever's on the bottom. I'm going to work out my two constants there. The second method I'll show later on is long division. I'll say partway through this why I prefer not to do long division unless you're asked to do it. This is why I'm going to show it you, but this is my preferred method here. So I've set it up as the answer is going to look. Get rid of the fraction. Times everything by x minus 3 to get 2x plus 7 is equivalent to a bracket x minus 3 plus b. Remember, I've got my three lines because it's true for all values of x at the moment. Until I start putting numbers in this case x equals 3 is a good start, then it's just equals. So when x is 3, the left hand side becomes 6 plus 7, 13, and then the right hand side, that becomes 0, it's just b, so b equals 13. And then the other thing I can do, because it's true for all values of x, I can match up coefficients. And I can match up the coefficients here of the x and say that 2 on that side, the only thing with x in is a times x, so 2 equals a. So this thing here will be equivalent to 2 plus 13 over x minus 3. And that's my preferred method of doing it. Long division. Long division, whatever I'm divided by goes at the front, into the 2x plus 7. It's nice and straightforward in this case here. I consider the first terms alone. X's into x's goes twice. I've got my 2 there to tell me I've finished. I work out my remainder, 2 lots of x minus 3, which is 2x minus 6. I bracket it, I minus it, I put a line under there to work out the remainder. The first part should always go, that's the whole idea. And then plus 7 minus 6 is plus 13. I've got my answer. It looks easier at this stage, so it becomes equivalent to 2 plus 13 over x minus 3. It looks like there's less going on. We'll come back to long division though when we do one of the other examples. So similar, quadratic over linear, what I'll be doing here, set up the whole number part, in this case ax plus b, because it's different orders, and then plus c over x minus 2. Get rid of the fraction. X squared minus 3x plus 10 is equivalent to all of ax plus b times by the bracket, and then plus c. Choose an x value to make that lot equal to 0, x equals 2, to give me 4 minus 6 plus 10, 14 minus 6, 8 equals c. Match up coefficients of x squared, because there's only one x squared there. There's only one way of getting an x squared there, which is a. And then to get b, there's no way I can get b without using these answers that have gone before. So I can either stick another value of x in, or match up coefficients. Matching up coefficients is okay, but sticking x's naught in is also okay. I get 10 equals minus 2b and plus c, which is plus 8. So minus 2b equals 2, b equals minus 1. So my answer then is this is equivalent to ax plus b, x minus 1 plus 8 over x minus 2. Okay. Similar for third example, 1c. It's a 2x squared one. It's still quadratic over linear. My setup is exactly the same as before. Ax plus b plus c over x plus 2. Notice, as I say, the setup there is exactly the same setup. The only difference is different function on the bottom of the fraction, but the method is exactly the same. Get rid of the fraction. So ax plus b times by the bracket x plus 2 and plus c. X value to make the bracket equal 0, x equals minus 2. Be careful with minuses. I've got plus 4 times 2, 8, minus 6 minus 5, 8 minus 11 minus 3 is equal to c. match up coefficients of x squared. 2 equals ax times x, a, and x equals 0 to get the b term, minus 5 equals 2b, and plus c, which is minus 3. 2b equals minus 2, b equals minus 1. So my answer then becomes equivalent to ax plus b, 2x minus 1, and then minus 3 over x plus 2.
1.
Okay, the fourth example, very similar to before, but it'll be slightly longer because I've got a cubic divided by a linear. So my setup, we find it x cubed divided by x, I have an x squared. So I need to have ax squared plus bx plus c, quadratic expression, and then plus d over x minus 2. And as before, times by the x minus 2 to get rid of the fraction, 2x cubed minus 3x squared minus 2x plus 2 is equivalent to ax squared plus bx plus c times by the x minus 2 and then plus d. And I can do the same sort of thing before. I need 4 things to do to find my 4 constants. X equals 2 gets rid of all that lot to help me find d. So because I've got a bit more going on, it might make more sense to actually show what I've got. 2 times 8 minus 3 times 4, 12, minus 4 plus 2. What does that equal there? 18 minus 16, 2 equals d. Okay. And as before, match up coefficients. The biggest term is x cubed. 2 equals ax squared times x, a. Nice and straightforward so far. Yeah, so we're happy with that. For the other two, I have to involve whatever's gone before. I can't avoid it. I'm going to do x equals 0 again, because that at least helps me find c. So 2 on the left hand side equals c times minus 2, minus 2c, and then plus d plus 2, which gives me c equals 0. It could be, as we found here, that some of these b and c terms could be 0, but a can't. I need to have a quadratic equation, quadratic expression there. And the last one, to find b, I can either stick in another value of x or match up another coefficient. So I might match up coefficients of x squared and say that minus 3 on that side equals a times minus 2 minus 2a minus 4, and then plus b. B equals 4 minus 3, b equals 1. So my answer then becomes, going back to this one, a 2x squared plus x, and then plus 2 over x minus 2. Lots of 2's. Next example is now where we've got a quadratic on the bottom. It's already been factorised, bracket times bracket, and this is where my setup, quadratic over quadratic, constant, and then plus b over one bracket, and then plus c over the other bracket, is much better than doing long division. All long division gives you is the value of a, and then you would have to do a partial fraction setup when you've got bx plus c, something x plus something, over x minus 1 and x plus 2. You would still have to split up the fraction as something over x minus 1 and something over x plus 2. It's a lot more long-winded than this setup here. So here's my setup. I'm then going to just simply times by both the brackets, get rid of the fraction. 2x squared plus 1 is equivalent to a times both brackets plus b times the second bracket and plus c times the first bracket. And this is now nice and straightforward because I can stick in x equals 1, 2 plus 1, 3, and that eliminates that one and that one to give me b, 3b, b equals 1. I can stick in x equals minus 2, minus 2 squared, 4 times 2, 8, plus 1, 9, gets rid of that term and the b term to leave me with c times minus 3, minus 3c, c equals minus 3, and match your coefficients of x squared. 2 equals ax times x, 2 equals a. Nice and straightforward. So my answer in this case is 2 plus 1 over, again, the right way around, x minus 1 minus 3 over x plus 2. Much more straightforward than doing long division and then partial fractions. Similarly, slightly longer because it's cubic over quadratic. I've got a little bit more going on. I'm going to end up with a linear expression plus c over x plus 1 plus d over x plus 4. Get rid of the fractions again, get rid of the denominators, times by both brackets to get x cubed plus 3x squared plus 10 is equivalent to ax plus b times both brackets plus c times the second bracket and plus d times the first bracket. And as before, sticking x equals minus 1, minuses, a bit more going on, so take your time over this one and say I've got minus 1 plus 3 plus 10, 13 minus 1 equals 12, and that gets rid of everything with the minus 1 in, which is the first term, this term, and gives me there 4 minus 1, 3c. C equals 4. Sticking x equals minus 4. And gives me minus 64. 3 times 16 plus 48 plus 10, which is plus 58, which is minus 6 equals, gets rid of that one, gets rid of that one. Minus 4 plus 1 is minus 3, minus 3d. D equals 2. And as before, x equals 0, do the x cubed first. 1 equals a times x times x, ax times x times x, is a, straightforward. And b has to use at least one of these things here. X equals 0 or coefficients of x squared. 3 on that side. How am I going to get x squared here if I did b times x times x? It's long-winded now, I've got this one. I'm regretting doing this already. I've got that times that times that. So ax times x times 4, so it's 4a, 4. Or it could have been ax times 1 times x plus 1, and then b times x plus b. So b equals minus 2. So I end up with equivalent to x minus 2 plus 4 over x plus 1 plus 2 over x plus 4. And that's obviously quite a long-winded question with a lot of marks going on there, a lot of things to find, but that doesn't look simple, but it's the simplest way of actually getting this expression here rewritten like that.
1.
Okay, the last two examples wanted to rewrite fractions in these sort of forms here without going on to the partial fraction part of it. So it's just rewriting quadratic over quadratic as linear plus my remainder over x squared minus 1. So in this case here, it wants to compare doing long division and then matching coefficients. So long division, I've got to think, what do I have to times x squared by to get 3x squared? Times by 3. And then work out my remainder by doing 3 lots of that. It's interesting, by the way, to put the 0 in to help me with working out my remainders. And then I've got that cancels out, minus x minus nothing is still minus x, and then plus 0 minus 3 is plus 3. Be careful how you write this answer, because then my function becomes a3. Don't write minus x plus 3 over x squared minus 1, because that means minus the whole of the bracket. I would write plus 3 minus x over x squared minus 1. because it's making sure that that term there is positive. How I'd written it before implies that the plus 3 is actually a negative term because it's treating that as a hidden bracket. If you're going to write the minus there, you need to make sure that that is that, and that's equivalent. So it's confusing with that the first term here, the x term being negative. Avoid it if you can by writing plus 3 minus x over. And match up coefficients, I've done the setup as we would do, and I can just match up coefficients. X squared, 3 equals a. I can stick in values of x. X equals 0 is a good one. 0 equals minus a, which is minus 3 plus c. C equals 3. And then, I don't know, x equals 1 does the job as well. 3 minus 1, because that makes the a 0. 3 minus 1 is 2, equals 1 lot of b, plus 3, and b equals minus 1. So I've got exactly the same answer as that one there. And the last example, very similar. It's quadratic over quadratic. So I've got p plus qx plus r over that. And I'm just going to do what I did for the last one there. Get rid of the fraction. 4x squared minus 7x minus 61, big numbers, is equivalent to p times both the brackets, x plus 3, x minus 5, plus qx plus r. Match up coefficients of x squared. 4 equals p. Stick x's 0 in is one option. Minus 61 equals minus 15p minus 60 plus r. R equals 60 minus 61. R equals minus 1. And then, I don't know, x equals 5 makes that one 0. And I've got 25 times 4, 100, minus 35, minus 61, which is minus 96. 4 equals 5q plus r minus 1. Q equals 5 over 5 equals 1. So what does fx equal then? P, Q and r, got everything. 4, q is positive, r is negative, so I'm okay with plus x minus 1 over x plus 3, x minus 5. And that's the end of all those examples.